All right, this video is a review for the quiz. The quiz is on solving rational equations and graphing rational functions. Okay, so it's a quick quiz review. I only have 3 questions. I have 2 equations and 1 graphing. Okay, so number 1, solve and check for extraneous solutions. What I'm going to do first is I'm going to factor all the denominators wherever I can factor. Okay, so x squared minus 36, that's the difference of 2 squares. So that fact is to become x plus 6 times x minus 6. Okay. And I have plus 2 over x minus 6 equals 1 over x plus 6. Now what I'm going to do is I'm going to find the least common multiple of the denominators, and I'm going to multiply every term by that. Okay, so the LCD is going to be x plus 6 times x minus 6. Okay. So what I do, and I'll do this in blue, is I'll multiply each term by the LCD. Okay. So the LCD times the first term. Plus the LCD times the second term. Equals the LCD times the last term. All right, so we have a lot going on here. Okay. The good news is that a lot of stuff is going to multiply out, and there should be no more fractions. That was the whole point of doing all that. So for my first term, the x plus 6 and the x minus 6, those multiply out, or those divide out, and you have just x left over, plus, okay, so again, so if you're confused, I'm just crossing out the common factors. These x minus 6's multiply out, so you have 2 times x plus 6 left over, equals, over here the x plus 6's multiply out, and you just have x minus 6 left over, times 1, but that's meaningless. Okay, so x plus 2x plus 12. Combine like terms, 3x plus 12. Subtract the x. So you get a 2x. Subtract the 12, so you get negative 18. And then it gives you x equals 9. You have to double check and make sure it does not make any denominators equal 0. If you substitute x equals 9 here, you have 9 squared is 81. 81 minus 36 is not 0. Okay? If you do x of 9 minus 6, that's not 0. If you do x of 9 plus 6, that's not 0 either. So none of the denominators become 0. So x equals 9 is not an extraneous solution. So that is the answer. I'll box that in. That's the answer. Actually, negative 9. My bad. I meant to put negative 9. I forgot the negative sign. Let me fix that really quick. There we go. I added in the negative sign. I forgot to put the negative sign. So negative 9 is the answer. But everything I just said still applied, okay? Because negative 9 squared minus 36 is not 0. Negative 9 minus 6 is not 0. And negative 9 plus 6 is not 0. So none of the denominators become 0. So that means this answer works. It's not an extraneous solution. The answer works. Okay? Number 2, solve and check for extraneous solutions. Okay, I'm going to factor first. This is the difference of two squares, so when I factor that, it becomes x plus 3 times x minus 3. Minus 1 over x minus 3. Equals 1. Okay, this one has an LCD of x plus 3 times x minus 3. So what I do is I multiply every term by that LCD. I'll do that in blue again. Okay, so multiply every term by the LCD. So the LCD times the first term minus the LCD times the second term. Okay. Equals the LCD times the last term, which is just 1, so you can kind of ignore that. And let's cross out whatever divides out. Okay, so these cancel out or divide out. These divide out. These divide out. And let's see what we got left over. We have 6 minus x plus 3 times 1. I don't have to write that. I don't have to put the times 1, I mean. Equals x plus 3 times x minus 3. Okay. Let's distribute the subtraction sign. So 6 minus x minus 3. And on the right, let's multiply those together. Now, hopefully you recognize it's like the difference of two squares. So it's just x squared minus 9. If you need to do the multiplying and the distributing out, go ahead and do that. Let's combine like terms on the left to get 3 minus x. Let's get it equal to 0. I like to keep the x squared positive. Now, we're going to factor that. That's a plus sign. I meant to put a plus sign right there. Okay. So we got it equals 0. Add x, subtract 3. So x squared plus x minus 12. Find two numbers that multiply to negative 12 and add to positive 1. Okay. So that's going to give you the following answers. Okay. You're going to get x equals negative 4, and you're going to get x equals 3. You have to check and see if any of them are extraneous solutions. Do either of them make the denominator equal 0? Any denominator. Let's start with negative 4. Negative 4 squared is 16 minus 9. Okay, so that's not 0. Perfect. Negative 4 minus 3 is also not 0, so that one's good. X equals negative 4 works. Let's box that in. X equals 3. 3 squared is 9 minus 9 equals 0. Uh-oh, that one does not work. That is an extraneous solution. Okay, so don't circle x equals 3. If you do, you lose points. It's not an answer. It's called an extraneous solution. You don't have to write that on the quiz or test, but I just want you to know that it's not actually a solution, so don't circle it. Okay. All right. one graphing problem. Here's what I'm going to do. I'm going to factor up top. I'm going to do the factoring up here. And also ask you to fill in these 5 statements right here. When we factor the numerator, we have 3 as a GCF times x plus 3 over. When you factor the denominator, it becomes negative 4 and positive 3. Divide out the common factor of x plus 3. And we get the following. We get 3 over x minus 4. All right. Now let's run through all our 5 things we're asked to find, and then after that, we may need to get some additional points to make our graph look extra nice. Okay? Here we go. Let's get the x-intercepts first. For the x-intercepts, you have to factor if necessary, eliminate the common factors, and then set the numerator equal to 0. Set the numerator equal to 0. 3 cannot equal 0. That means that there are no x-intercepts. Okay, because think about it. The numerator 3 cannot equal 0. That makes no sense. So I'm going to say that there are none. None. For the y-intercepts, do the y-intercepts next. That's when you replace, when you substitute 0 in for x. Okay. You go back in the original equation, it was 3 times x plus 9. So instead of doing 3 times x, I'm going to do 3 times 0 plus 9. Divided by, it was x squared minus x minus 12. So I'll do 0 squared minus 0 minus 12. So the numerator will be 9. The denominator will be negative 12. Which simplifies to negative 3/4. So the y-intercept is going to be 0, negative 3/4. Let's graph that as we go. You can just estimate that. Okay, negative 3/4, somewhere between 0 and negative 1, close to the negative 1, so like right there is good. Okay. Graph it as you go. Okay. Next, we're going to do the holes. Let's do that down here. You take a common factor. In our case, the common factor was x plus 3, and you set it equal to 0. That gives you x equals negative 3. And now, to find the y value of the hole, you take the x value that we just established, and you substitute that into your new function, which is this one right here. So 3 over x minus 4. So 3 over negative 7. So the whole will be negative 3, comma, negative 3/7. Let's graph that as well. Negative 3/7. That's good. Make sure you don't have this hole filled in. Okay, it should be open. Next, let's do the vertical asymptotes. So again, if you think back to the lesson, the previous lesson, you have to factor if necessary first, eliminate the common factors, and set the denominator equal to 0 and solve. So after we eliminate the common factors, we set the denominator x minus 4 equal to 0. That gives you x equals 4, so that's your vertical asymptote. Let's graph that. I'll do a dashed line. The graph cannot touch that point, that line. The horizontal asymptotes are next. The degree of the numerator equals 1. The degree of the denominator equals 2. If you think back to what scenario that is from yesterday's lesson, that's where the asymptote is y equals 0. And let's graph that. This one is really hard to see because it's on the axis, but I'll just graph it anyway. Just maybe it'll help you see it better. You don't really have to do that since I'm the y-axis, since I'm the x-axis. Now let's do some additional points. Now I like to go back to the original problem. I would suggest you do that. Okay. Let's get one more on this side of the asymptote. How about we do x equals 3? I'm going to substitute that back into the original problem. So the original problem is 3 times x plus 9. So 3 times 3 plus 9 over 3 squared is x squared minus x, so minus 3, minus 12. So now the numerator, 3 times 3 is 9, plus 9 equals 18. The denominator is 9, 3 squared is 9, minus 3, minus 12. So that'll be negative 6. That equals negative 3. So it means my additional point is 3, negative 3. Let's graph that. 3, negative 1, negative 2, negative 3. At this point, I'm good on that side. I'm just going to connect those. I know my asymptotes. Again, this is not perfect. We're sketching it as best as we can. I'd say that's good over there. But now let's see what happens on this side of the asymptote. Let's see what's going on. So let's get a couple more additional points. Let's do x equals 5. And maybe we'll do one more after that. Let's start with x equals 5. So we have 3 times x plus 9 for the numerator. So 3 times 5 plus 9 over 5 squared minus 5 minus 12. Okay, so the numerator is 15 plus 9. The numerator is 24. The denominator is 25 minus 5 minus 12. So that's 8, which equals 3. That means you have the additional point 53. graph that. 1, 2, 3, 4, 5. 1, 2, 3. Okay, at least we know which direction we're in now. Let's do one more additional point on this side. Let's do 7. How about we do 7? Let's do x equals 7. After that, we're going to stop. Okay, so 3 times x plus 9, 3 times 7 plus 9. Over 7 squared minus 7 minus 12. Okay, so the numerator will be 21 plus 9 is 30. The denominator is 49 minus 7 minus 12, which is 30. That equals 1. That gives us the point 7, 1. Let's graph that. I got those 2 points. I have my asymptotes, so I'm good. Let's go like this. Okay. Just a sketch. Say that's good enough. And that's the end of that lesson. That's the end of the quiz review. The quiz is on solving rational equations and graphing rational functions.